The distribution of scores on a certain exam is n30, 5. The n means it's a normal distribution, 30 is the mean, and 5 is the standard deviation. For the first part here, part A, we want to basically sketch a normal curve that has this data on it. So I'm looking for a mean of 30, so it can't be this graph because the middle is 40, so it has to be either B or C. And they're asking us to mark the standard deviations along the axis. So that's going to be C. Here we're counting by fives, and each time that you do, you've gone one standard error. All right, we'll continue. Next, we want to determine the probability that a randomly selected score will be less than 20. So like on your picture here, you're at 20 and you want to be less than it. It says to use the empirical rule to do this, so I'm actually going to bring up a diagram of the empirical rule. It tells you that if you know the middle and you're counting by standard deviations, how much of the data have you collected? And it breaks it down in terms of percentages. So if you're within one standard deviation of the middle, that's 68% of the data, 34% on the left and 34% on the right. We're asking about being, let's see. Okay, so we are 1, 2. We are 2 standard deviations away from the middle going in this direction. So the way you can figure out the correct percentage off of this chart is by going 2 standard deviations away and then adding up these two percentages because it would correspond to this area. So that's 0.15 added to 2.35. That's 2.5%. So that's the value that we want here. So, I mean, this question could be phrased differently. It could be, what if you're above one standard deviation? Like, what would the answer be then? And you'd get that by adding up these values. That means you're greater than one standard deviation away from the middle. But continuing here, which graph shows the distribution with the region shaded under the normal curve that corresponds to this percentage or probability? And that is graph B. We're starting at 20, which is 2 standard deviations away, and we're less than it. So that's where the area is shaded. And that is it for this problem.